All right, on to division. Oh boy.
Who?
What? So division.
That still exists.
Y'all did long division, right?
Yeah.
Oh, good. So that makes life easy because that's just how we're going to do it here. Fortunately, division is going to get a lot trickier. So we're going to go ahead and look at it. Okay, so you have your divisor, your dividend, and when you do integer division, you remember you get your quotient and then the remainder as well, or two answers that you get. So long division approach, if the divisor is less than the dividend bits, then do the subtract, otherwise you keep going down. So notice the one's 4, so you gotta wait till you get 4 over. We're gonna get to this step by step in a bit, but we're just gonna stick with this for now. So then you subtract it. Y'all did this, right? Subtract the number, keep adding the digits until you get again something larger, subtract, and then when you're done with all your digits or your bits of your divisor, whatever's left over is your remainder, and then your quotient's up on top. Everyone good? All right. Hey, look, this is what divisor looks like, or a divider hardware. Notice we're going to have the divisor. It's in the left half, so when it shifts down, it's going to be downshifted. So let me go ahead and write the numbers up on the board. We're doing, what is it? Oh my goodness. Divided by 1, 0, 0, 1, 0, 0. There's actually an extra 0 right here.
Whoa.
You okay?
Even the one from on the board, you're missing a number.
It's 1001010.
There you
We're good?
go. Yep.
Okay. So the divisor, how many bits are in the divisor?
64.
Right, so up on the board it's 64. We're dividing a 4-bit number into an 8-bit number. So the divisor in this case, oh my goodness, what was it going to be?
2.
I always forget. Let me get my cheat notes out real fast. Good.
You cheat sheet.
Oh, definitely got my sheet. Yeah, that's what I thought. It is 16 bits. I was hoping it wouldn't be. Yeah, it really was. 1, 2, 3, 4. 1, 2, 3, 4.
This is why we let the machines
1,
do it.
2, 3, 4. 4. It helps if you group it by 4s. And I just lied because the divisor's in the upper half. Wow, that was wrong.
Yay.
There. It's in the upper half. The 2 halves of 16 bits are 8 bits. So you have a 4-bit number. Putting in the upper half is just the first 4 bits of the upper half. Okay.
Sure.
Makes sense.
And no one stopped me because the divisor is actually, yeah, no, I got that right. What's the other one? The other one's a quotient. Remember, the quotient is the answer. So that's going to start off at 0. We're not going to touch that one, but the remainder is the dividend. We don't do that yet. And the remainder, great, 60 bits as well. Initially the dividend. All right, here we go. 1, 2, 3, 4. 1, 2, 3, 4. 0, 1, 0, 0. 1, 0, 1, 0.
Sounds so excited.
Oh man. Division is a bit of a,
Pain in the butt.
yes. And your quotient, spell it correctly.
No one can spell it correctly.
No one can spell this correctly. All right. It starts off all zeros, and it's 4-bit or 8 bits. Okay.
Oh, great.
So, what do we do? Well, subtract the divisor from the register of the remainder and place the result in the remainder. If the answer is greater than 1, shift the quotient to the left and set the rightmost bit to 1. If it's less than 0, meaning it's negative, aka you can't do that subtraction yet, you have to restore the adder by re-adding that number back to it, and then shift the quotient to the left and set the least significant bit to 0. Shift the divisor register to the right, and then once you've done your bitness plus 1 iterations, you are done. Everyone ready?
It's ready as all ever be.
All right. All right. Oh, wow, no one's going to be able to read that on the internet. Sorry about that. All right, so I'm not going to write subtraction. We subtracted the divisor from the remainder, aka remainder minus divisor. Would we get a negative number? Yeah. So for your homework, just to save you time, just write the word restore, meaning that you did the subtraction and you had to restore it. I got it. You shift the quotient over, but we don't do any shifting, so let's go over to step 1. Step 1. Oh, what happened to the divisor? It got shifted to the
Right.
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 Sure.
The divisor's got to get smaller so that remainder will get useful. All right, so let's go ahead and write that out. All right, the remainder's still the same, quotient's still the same. You can use those little ticker quotes. I got it. We're good. All right, if I were to subtract the divisor from the remainder, would I get a negative number? All right, let's write the word restore. On step 2. What gets shifted? The divisor. Keep in mind the quotient gets shifted, but when you shift all zeros, it doesn't matter. All right. Now again, do I get a negative number?
Yeah.
Yep. All right. Restore. On to step 3. Ah.
Does this mean we have 15 steps?
Hold on.
This one, no, you're doing it by the bitness, so you're going to have 9 steps. The bitness.
Well, restore.
Restore, all right. Might be a while, guys.
I'll just take a quick nap.
All right. I wish I could.
So let him restore.
We're still restoring?
Yep.
All right.
We're almost there.
We're almost there. All right, step 5. So we downshift this.
0.
Is it a restore? No, we subtract. All right. All right, I'm going to put a minus sign. I'm going to write it out again. And what does that equal? Well, a bunch of zeros. And 0, 0,
0,
0,
0.
0, 1, 0, 1, 0. And then, what are we going to do to the quotient? Shift it to the left and then
Add 1.
add 1. Okay. So it was that number before, dot, 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 dot. It's going to become, okay, at the end of it. Notice that there's multiple sub-steps inside of these steps. So I did a dot, dot, dot because it's really up here. You would shift it, then you would add 1. That's going to become very important pretty soon. All right, step 6. What do I do first?
Make sure it's
Right.
right.
Shift the divisor. All right.
Look, another restore.
Is it a restore?
Mm-hmm.
Yeah, it's a restore.
You have 2 more.
Okay. And so he's going to stay the same. What happens to this guy? So he's shifting. 0 was. going to be hard for the people to see. 0, 1, 0. All right, step 7. What happens to the divisor?
Oh, we should finish.
All right.
Space it out.
What are we doing?
Restore.
I just put
Yeah, the
store.
answer way when you shift.
What do we do with the quotient?
Shift.
Shift it. Okay. Step 8, which is the 9th step, because we started at 0, so this is the final step. We're able to, okay, I'll try and help you out there. All right, what do we do?
Shift.
First we shift. Then we
Subtract.
subtract. 1, 2, 3, 4, 1, 0, 0, 0. So we subtract it, and we're going to get 0, 0, 0, 0, 0, 0, 0. And you got 0, 0, 1, 0. Okay, now what are we doing with the quotient? What do we do first? First we shift. So it goes 0, 0, 0, 0, 1, 0, 0, 0. Then you turn the last bit on. Good, y'all can kind of sort of see that. All right, and now you write the word stop because you've done n plus 1 operations. So there's your answer. All right.
Oh boy.
So that's the only reason you know to stop?
Yes. Yeah, that's the only reason you know. You have a set number of operations.
I was wondering, I was like, I feel like this could go forever.
Yeah, it could. But just keep on going. Yeah, it could go for a
Yeah,
while.
it's not
Yeah. All right.
infinite loops.
So what's the problem with this hardware?
It takes.
It takes too long. Division ended up being a very tough thing to do. So it takes too long, sure. What's another problem?
Remainders.
Well, no. What's the problem
There's a
with
lot
the
of
remainder?
parts.
You always have a remainder because when you do modulus, keep in mind that modulus and division, when you write your program, are the same operation. You're just getting a different one of the two answers that popped out. Because you have the remainder right here, and then you also have the quotient or the final answer. But what's another problem with this hardware?
Too much hardware.
There's too much hardware.
Yeah, there's too much hardware.
There's like a lot of registers and a lot of space.
You can trim it down.
We could trim it down. What could we do?
Just get rid of the. I feel like we can get rid of the remainder.
No, we
Get
need
rid of, no, you need the
Just
remainder.
get rid of it.
Get rid of the divisor.
Well, then we wouldn't have to do division because there's no way to get the answer, right?
Exactly.
That's one way to do it. Avoid divisions in your
I guess
code.
we could just get rid of the quotient. We just leave the remainder, right? So.
Right, so you could merge the quotient and the remainder together.
Oh, okay, yeah.
Mmm.
Hmm.
Mmm.
Is that what they do?
Yep.
Let's
What
find
else
out.
could we do?
Cut something in half.
Right, what things could we cut in half?
ALU.
The ALU, yep, good guess.
Divisor.
And the divisor. All right. This gets really confusing.
Yeah.
Ignore these arrows. I don't know why they put them in these slides. It makes no sense. Every time I look at it, I get confused, and I have to pull out my notes because it's just kind of dumb.
Oh, you have actual notes instead of a
Oh, I
sticky
have
note.
notes.
Instead of a sticky note.
Yep. Okay, so
That should scare us.
what?
So that should scare us.
That should scare you.
It no longer fits on the sticky note.
Oh, yeah, no, it doesn't. All right, because this time what we're doing is the answer, ignore this picture because it's dumb. We're going to put the quotient on the right side, and then you're only going to operate on the, where are we? You're only going to operate on the left side. There we go. And as you shift up, the remainder will be on the left, and then the final answer will be on the right.
Okay.
Yep. All right. So, give me some numbers. Give me a 4-bit number.
0, 1, 0.
0. What was it? 0,
0, 1, 0,
0, 0. Okay. Smart man. Only put 1 0 in there.
1,
Good.
1.
1 1. Whatever. All right. Give me an 8-bit number with
1.
more than 1 1 in it.
1.
What?
1.
1?
0, 0, 0, 0, 0, 1.
All ones.
Why can't you do all
It's
one?
got more than one.
1, 0, 1, 1.
All right. Great.
Oh, we're gonna die.
Yeah. This is where.
There's only 9 steps. We can do this.
Yeah. Usually this is the part where we stare at it for about an hour until we finally get it right.
Oh, great.
But maybe you're the smartest class ever. Okay. So what's the divisor? That thing? All right. Hey, look, the divisor never gets shifted. Isn't that nice?
Yes. We'll go with that.
All right, and I said that the remainder goes on the right half. So
Yeah.
first we pre-fill all our zeros. Okay,
Yay.
who's ready?
I did the last one.
We don't want Jonah all the time.
Yeah, we gotta give me a break.
Who hasn't done that yet?
Have you done one yet, Matt? Oh.
Yeah, he has.
I have.
I'll do it.
You'll do it? All right, PJ. Thank you.
Take them off for the team.
Just go under the cord.
Do it one of those? No, we're doing this.
Oh, it's okay. We haven't switched over yet.
Oh yeah, we haven't switched yet. Can I eat your coffee real quick?
Yeah, he's
I
gotta
understand.
fuel up.
I know.
All right.
Yeah, let's put that down first, or you can.
No, we got to make it as unprofessional as possible. That's what I've determined in life.
I love this one.
Let's see.
Okay, so first off, you try and subtract the divisor from the top part of the remainder. Is that going to give you a negative number? The top half?
Yes.
Yes. So we are doing
Restore.
restore.
But you like
means
look at
that-
it as like 0, 0, 0 and then the divisor.
Yeah.
Okay.
What's the, when you said top half, what did you mean by that?
The top-
First
so there's
8
Zeros in the
bits.
remainder.
So these.
Yes.
Yeah. So the divisor is
That
really
doesn't
0,
work.
0, 0.
Yeah, so we got
Zero.
to
So we need to shift.
yes, you write restore, or just write restore to the side or wherever. We
Just write
have not
on.
much room.
West.
All right, perfect. Then we can go to step 1. Do we change anything with the divisor?
Nope.
Nope.
Just write that all the way
And then the
down.
remainder gets shifted up by 1.
Up.
Yeah, to the left.
left.
Yeah, to the left.
To the left, to the left.
To the left. To the left. Okay, I still got that.
Oh boy.
And we add a 1 at the end or a 0?
0.
0.
Okay.
So
So
do it again.
Still a-
Is it-
still a
Still
zero.
restore.
Okay, so restore, restore. All right.
again.
Yep.
Mhm.
All right, so I can do it now.
All right. So first subtract it.
This is.
Just write what the answer would be after you subtracted it.
Where? Here.
Right on.
Is
Yeah,
it?
right.
Is this still step 3?
Yeah, we're still in step 3. So step 3 is gonna have multiple parts.
So it would just be 0.
Mm-hmm. And then go ahead and write the rest of it. Yeah, the rest of it, and you're going to turn on the last bit.
Ooh. Interesting.
All right.
Oh, right in the glare.
Okay.
Wait, can you? Why is the last one become 1?
because you were able to subtract it. Remember, at the
Yes.
very end of it, your bottom half is going to be the quotient or your answer,
Got
and the
it.
top half will be your remainder. So you got to turn that one bit on. All right, now go to step 4. If you do it this way, it's a lot easier to write out than the book way. The book way is just confusing.
So now do we start subtracting?
Shift it. Remember, you got to shift it to the left.
This?
No, the
This.
Back to
remainder.
the
Yeah.
same thing you did before.
Yeah. Remember, you always shift it the remainder to the left. All right. Now, can you do the subtraction?
Here or here?
No, it's restored.
Remember, it's the top half. You always
Just the
subtract
top
from the
half.
the top half.
So no.
So the answer is no. So put restore on the side because you're doing a restore this time.
Okay.
All right. On to step 5.
So we're just gonna shift.
Yeah, just shift until you
Until-
take subtract.
These
But
4 start here.
For your homework in your midterm, just write every step out. So if you don't mind, PJ, please write them out. Yeah. Don't forget to put step 5 on the side because you're on step 5 now. This one especially can get tricky. So if you write it all out, it's gonna.
Yeah, I messed up between 3 and 4. But can you put a line between 3 and 4?
Oh yeah, can you put the horizontal lines for all the steps? Yeah, there we go.
These are bad lines, I apologize.
It's okay. And do it for yeah.
Between 2 and 3, that's it.
All right. So it's restore because you can't subtract from the top half. Perfect.
This
Well,
word.
hold on, you
Well,
can
hold on.
subtract.
Yeah, you can subtract from that one.
I did that.
So subtract it.
Yep. So we got to subtract it out.
We've got
And you turn on the last bit. Yeah. Perfect. All right. Now step 8, which should be your final step.
because we're n plus 1
Yep. Yeah, and plus 1. We have
for the
8
this.
bits. Yep. So we're doing 9 steps. Shift everything up. Yep. Can we do anything? All right, so we're done.
So this is your remainder.
Yeah, your remainder's right there.
Just hold.
Wait,
Hold on, wait a minute.
on the.
Oh.
Oh,
your-
yeah.
it should be 1-1. Yeah,
Did it again.
There we go. 0, 0, 1, 0. Yeah, there we go. All right.
Remainder 3.
So we're saying the remainder is 3, and the what's that? 8, 16, 23, 32 plus 2, 34. So, okay. Well, let's see if that's actually correct.
So when we're adding the remainder, do we add these 2?
Yeah, it's 2 plus 1, which is 3.
I don't understand that.
So remember, these are binary numbers.
Yes.
So this represents 1, 2, 4, 8, 16, 32, 64, 128. So this is, the 1 is on and the 2 is on, so you had 2 and 1 to get 3.
Right.
Okay.
So I guess the part I was confused about is you just leave that alone.
Yeah, you're done here.
Okay.
Technically, if you want to be accurate, this would be your remainder.
Oh, I'm in the way.
It's okay. And this would be your quotient. Okay. Did we get that right? I hope so. 1, 2. So that's 4 into, what do we got? 8, 16, 32, 64, 128. 128 plus 8 plus 3. So that's 134, 137. So that would be a 3, carry the 1, 17. Wait a minute. No, I did something wrong here.
139.
130. It is 139.
Yeah.
Yeah, thank you. Whew. We're going to be sad for a moment here. So 34 with remainder 3. All right. Hey, the remainder's correct, and that's 34. Good job. You're the first class to get this done, to get this right the first time. So we're just going to say we got it perfect, and everyone's got it.
Yeah.
So, when doing this in the homework, you do the same thing whether it's asking you for the quotient or the remainder. You just look at a different part of the answer.
Right.
Yes.
Okay.
The question is going, the book is going to ask you the first way and the optimized way. I highly recommend you do it the way I presented on the board, because the way the book explains it, it doesn't make much sense.
So
The book does.
it tells you to do it 2 ways, but we should do it this way for both.
Yeah, if you do, the book is confusing because it's trying to put the numbers like this and then shift them out like that.
Oh gosh. Oh,
Right,
no.
it doesn't,
No.
it's confusing.
That's
Yeah,
not.
yeah, you like that? Like that? So instead, if you just do it like this, it only requires one arm, and then everything's.
Our
I would
arms
say
don't go that far.
in the homework, you want us to do it the first way and then do it the way you showed on the
Yeah, it's gonna say the unoptimized way, and then it's gonna give you a picture of this. When it says do it the picture as in this figure, you can do it this way if you want to, I'll accept it, but I recommend doing it this way that we just did on the board.
Yeah.
Yeah,
The way we know how.
yeah. All right. Okay, guys,
We're done.
almost. Let's go and ask